All right, we'll go ahead and get started with the next section of notes here. This is going to be 8.4, and we're talking about parts of similar triangles. Okay, so date today is the 10th. Our objective for today is we want to be able to find different measurements and lengths using these properties of similar triangles. So we've talked a lot about proportions and different pieces of information that we know with similar triangles. Now we're just talking about more pieces and more information that we have with this, and it's still going to be based on the same idea of setting up the proportions correctly. Okay, so first off, a little review here. The parts that we're going to be focusing on today are parts that we've already talked about way back in Unit 5. So the first one, little review, is do we remember what a median of a triangle is? So remember, this isn't median of a data set like you'd see with mean, median, mode, and range, but this is the median of a triangle. Okay, and the median of a triangle is a line inside a triangle that goes from one point, okay, a line inside a triangle that goes from one point to the midpoint of the opposite side. Okay, a line inside a triangle that goes from one point to the midpoint of the opposite side. And remember, we said a way to remember this is midpoint and median both start with M. So for example here, we want to draw a triangle. Go ahead and draw this. Doesn't really matter what it looks like. Okay. Again, if we need a median, there's three total that we can choose from, so we just need to choose one of them. So we'll start at this point here, and then we want to go to the midpoint of the opposite side. So if I had to give a rough estimate, let's say it's about there, and this would be the median, the straight line there. Okay, that would be the median of that triangle. Okay, and we're going to use this for a different piece of information. Another thing that we talked about is what we call the altitude. Okay, the altitude of a triangle. Okay, and the altitude of a triangle is similar to it. It is a line inside a triangle. Okay, a line inside a triangle that also goes from one point. I'm going to say that goes from one point. And this time it's a little bit different. It's not going to go to the midpoint of the opposite side, but the information that we know is we can say that it goes from one point and is perpendicular to the opposite side. Okay, so this one's, like I said, similar, but a little bit different than what we see with median here. It's still a line inside a triangle. It's still starting from a point. So again, if I want an example with this, we'll go ahead and just draw a triangle. And I'll go ahead and just draw the same one so we can kind of see the difference between the two here. Okay, still have the same kind of triangle. Still going to start from this point at the top. But this time, it's not necessarily going to the midpoint, not necessarily going right here. But I want this line to just go straight down because I want it to be perpendicular to the opposite side. Remember, we said the median goes to the midpoint, or deals with the midpoint, and then the altitude deals with the angle that it intersects the other side. In that case, it's always going to be a right angle or a 90-degree angle. Okay? All right. So this is the two terms that we have. This is important for us, or we can relate this to what we've been talking about with similarity, because if two triangles are similar, then I can say two different things. Okay? I can say this. I can say, number one, if two triangles are similar, then their corresponding medians have the same proportion as the scale factor. So one thing that I know is that if two triangles are similar, then whatever scale factor I've found for those, it's going to have the same proportion as if I set one median, or one corresponding median, I should say, over the other. Okay? And then what's the other thing that I can say with this? The exact same idea, except with altitude. So I can also say their corresponding altitudes. And we'll just shorten this one here since we've already written the bulk of the definition in the other one. Their corresponding altitudes have the same proportion as well. We'll just cut it off there. Okay, same idea. Okay, it's the same proportion as the scale factor. Okay, so this is very helpful because that means we can use this to solve for different side lengths and angles if I'm looking at a median or an altitude here. Okay, so for example, let's say we're given these two triangles and I want to find x. Okay, if you need to, you can pause your video and sketch this here. But if I'm looking at this, I know these two triangles are similar because I have two pairs of angles. And remember, by the angle-angle similarity theorem, we can say that these are similar. And if that is the case, we need to figure out what x is, or in other words, what the length of this altitude is here. So best thing to do is I would want to find the scale factor. In other words, how much bigger is one triangle than the other here. So if I look, I'm looking for two sides, so not inside the triangle, but I'm looking for two sides outside the triangle that are corresponding. And I see those here. I have 20 and I have 15. Those would be in the same spot between these two triangles. So I can just say the scale factor is 20 over 15. Okay, and then if I'd like to, I can go ahead and reduce this as well. Okay, notice both of these numbers have a factor of 5. So if I divide that out, that's going to give me 4 over 3. Okay, so I have this here, and now I want to use this to find the length of this median. So if I want to set up my proportion, I'm just going to set 4 over 3. And then we're going to do the same thing with the altitudes here, excuse me. So I'm going to see 16 is in the first triangle, and x is in the second triangle. So I can set 16 over here and x over here. Okay, so just like the proportion problems that we've done before, there's not much different. As long as I keep the same side lengths all together in the right spot in the proportion, then I should be able to solve for these pretty easily. Okay, so notice we could cross multiply, but I also noticed to go from left to right, I would just need to multiply by 4. So I need to do the same thing over here, multiply by 4. So x is just going to equal 3 times 4, which is 12. Okay, simple enough. And remember, this idea of going from left to right, if you're not going to use cross multiplication, this only works with multiplication or division. Don't ever look at trying to see if you can add something. It's always multiplying or dividing. Okay, but simple enough, just using proportions. All right, so moving on to example 2 here. Example 2, same kind of thing. We're given these two similar triangles, and we want to find the length, or in this case, we're going to use x to find the length of SR. So again, if you need to, you can pause your video and sketch these here. But if I want to find the x here and find the length of SR, the best thing to do would be to find the scale factor. And what I notice is I don't really have two corresponding sides that are both numbers. But what I can do is I can set this up with two corresponding sides. I see this length SR here. I see this portion is going to be x, and this portion is the same, so this is also going to have to be x. And then same idea below here. If I have this portion, which is 3, this segment right here is also 3. So I have two side lengths. One of them is x plus x, or in other words, 2x. And then the corresponding side length to that would be 3 and 3, which has a length of 6. Okay, so this is technically my scale factor here. And we said that the scale factor is going to have the same proportion as the medians. And I know these medians, or I know these lines inside there are medians because I see they go to the midpoint of the opposite side. Okay, those two segments are marked for me there. So if I want to set up a proportion, I can say 2x over 6 is going to equal the same thing as this median, 13.5, over this median, which is 9. Okay, so sometimes you're not going to be able to find the scale factor, but you can always set up the same proportions with one another. Okay, and then here, there's a couple different ways to solve. One that I would just always recommend that I know is going to work is just cross multiplication here. So that means that I know 2x times 9 is always going to equal the same thing as 6 times 13.5. Okay, so 2x times 9 here, that's just going to simplify down, 18x. And then if I want to do 6 times 13.5, I could type that into my calculator if I'm not sure, but that is actually going to give me 81. Okay, 6 times 13 is 78, and then add another half, so add another 3, that would be 81. Okay, and then last step, divide by 18 here. Okay, we get x equals, and this is not going to come out to be a whole number, that's okay. Okay, this is going to come out to be 4.5 if I type this into my calculator. Okay, so x equals 4.5. Okay, but notice it wasn't asking us for the length, or it wasn't asking us for x, it was asking us for the length of SR. So I need to plug this back in here and find what SR is going to be. Okay, and we kind of see this here. SR is this side length that we already talked about. SR is just 2x. Okay, SR, another way to relate that is just 2x. So if that's the case here, I just plug it back in. So SR equals 2 times 4.5, which means SR is going to be 9. Okay, so make sure on all these problems, just like we've seen before, you're not stopping just at the variable. You're always double checking to see if you need to plug it back in. Okay, so that is the ideas that we can use with medians and altitudes. And then there's one more idea that's separate from this. It's what we call the triangle angle bisector theorem. Okay, the triangle angle bisector theorem. And it says this. It says if a line inside a triangle, bisects one angle. Okay, if I look inside a triangle and I see one line inside of it that is bisecting one of the angles, then what I can say is I'm going to say it splits that side, or I'm going to say that opposite side, into pieces that are proportional to the remaining two sides. Okay, if a line inside a triangle bisects one angle, then it splits that opposite side into pieces that are proportional to the remaining two sides. And like we've seen before, this is obviously more of a complicated theorem unless we can kind of see what it's saying here. So let's draw an example. Let's draw a triangle. Doesn't matter what it looks like here. Let's just keep it simple. We'll do this. Okay, and let's name this here. We'll call this triangle ABC. Okay. So we have triangle ABC here, and it says I need a line inside this triangle that is bisecting an angle. So for instance, let's use angle B here. Let's cut this in half roughly. Let's cut that in half. Okay, it might not necessarily be a median or an altitude, but it gives us these angles here. And let's also say that point where it intersects on the other side, that's going to be D. So I've taken angle B, I've bisected it, or in other words, like we've talked about, it means I've cut it in half. And it says it's going to split these pieces. So this opposite side here gives me two pieces, AD and CD. And so what I'm going to say here is AD over CD is going to be the same thing, or is going to have the same proportion as the remaining two sides. So I notice the remaining two sides that this hasn't bisected or intersected is AB and BC. So I'm going to say AD over CD is the same thing as AB, over BC. Okay, this is what my theorem is saying right here. Okay, so all we need to do when we're looking at these kinds of problems is we just need to use this idea in order to solve for different side lengths. And obviously we'll do an example with this here to close. Okay, all right, so last example, putting this into practice, making sure we understand how to set up our proportion. If you'd like to, you can take a sec and sketch this diagram for me here. Okay. So we're given this triangle. We see that this line is in fact an angle bisector. Okay, because it does give me those two congruent angles right here and right here. And with that information, I'm going to use that to find B. Okay? And if I really wanted to, I could label all these side lengths as well, or all these points to make sure I knew what I was referring to. But in any case, we need to set up our proportion, and we need to do the same thing that we just wrote down there. We said this opposite side here is going to be split into two proportional sides that have the same proportion as the remaining side lengths that I have here. So for instance, if I want to start with this one right here, let's start with B. We're going to say B over, and then we need this side length right here. Okay, well notice I don't have the exact length of that, but what I do have is I'm told the entire length of this line, or this side length, is 28. And so if I want to express this in terms of a variable, notice this is what I would get if I took the whole thing, 28, and then subtracted this piece here, subtracted B. So this side length right here, a way I could label this in terms of B is I could say this is just 28 minus B. Okay, that's one way to represent that side length. And so when I set up my proportion, I'm going to put B on the top and then 28 minus B on the bottom here. Okay, and then that's going to equal the same proportion as the two remaining sides that I have. So since B is on this side of the triangle, and I put that on top, that means 27, since it's on this side of the triangle, also has to go on top as well. So this is going to be 27 over, and then the remaining side here, 15. Okay, this is how you set up this proportion. I know it's more of a confusing type of problem than we've seen before, but we can still use this and solve this just like we've seen proportions in the past. Okay, so I can go ahead and solve this now. Again, my recommendation would be to just cross multiply. So we'll do this here. We're going to say 15 times B equals the same thing as, and remember, if I have a number and an expression, I usually put the number on the outside and then the expression inside the parentheses, and I do that so that it reminds me to distribute that number. So now I can go and simplify. I have 15 times B, or in other words, 15B, and then over here I have 27, and I need to distribute that to both terms. Okay, so 27 times 28, I can just type that into my calculator. It's going to give me 756, and then minus 27 times B, so that's minus 27B. Okay, and I understand the 6 and B look very similar, so I'll try to make one more distinct than the other. Okay, all right, and now I need to solve this, so we know one way that we could do that is we can add 27B to both sides. When I do that, these cancel. I have 15 plus 27B, that's going to be 42B, and then equals 756. And then my last step here, divide by 42. Okay, divide by 42. When I do that here, I can just type this into my calculator, 756 divided by 42, and that's going to give me B equals 18. Okay, so those are the notes for today. Assignment that goes with this is going to be the 8.4 exit ticket. If you guys have any questions with this, feel free to let me know. But either way, 8.4 is the assignment. All right, thanks guys.